Hello, this is Vairav Kumar Bhomik. I am a PhD student from IIT Guwahati, and here I am an operator for this electron beam lithography process. The system is connected to EDX, and for that we need to shut down the both PCs, the FECM PC and this also the EBL computer, and then after that we need to switch off this OP switch so that the whole system get turned off. The whole system is now turned off, and these two cables, these pink color cables, these are for EDS system. So we need to change these two cables while you are using the EBL. So this is a BNC cable, and this cable is for the EDS, and we are removing these two cables, and we will replace this two cable with the cable for EBL. So this black one, this is for EBL, and now this system is connected to the electron beam lithography system, and we will now on the whole system. Before loading the sample, we need to press this vent, we need to vent the system, and till this blinking, that is system is not ready, and we need to wait. So this blinking shows the indication that the system is yet not ready, and this shutter is closed now, and when this blinking is over, we can open the exchange chamber. Before going to start the lithography process, we need to prepare the samples. We need to coat the electron beam resist on the sample, and while loading the sample, carefully we need to mark a small scratch in the corner of the sample like this, a very small scratch. It will be used as a reference during the writing process. Now we are going to load the sample in the exchange chamber. Again, we need to evac the system, and we need to wait for the system gets ready. Using this rod, we can insert the sample inside. And since our sample holder has a height, so we need to give a offset. We are giving here a 13 mm offset. So we are going to start the system, and before that we need to set this acceleration voltage to 30 kV and this working distance we are setting this working distance to 8 mm. So here we are setting the working distance as 8 mm, and this stage is moving now, and we already applied an offset 13 mm. We applied this due to the height of this sample holder. So we always need to apply an offset of 12 mm or nearly 13 mm. In the next step, we need to use the on the hardware. So here this is the current monitor, and this is the Genon row, and this is the blinker controller. So we need to on both of them, and there is a sequence before keeping on the systems. We need to on the first the Genon row controller, and then we need to on this Genon base. So there is a backside, there is a switch, and here we have on the system, and after that need to on the system. Now we can on this monitor. While winding up the system, we need to follow exactly the reverse process. That means we need to off this monitor first, then we will off this Genon base and Genon row. When you on the hardware, we need to on the first, we need to on this draw, and then we need to on this base, and then we on the monitor, current monitor. And while winding up the system, we will exactly follow the reverse sequence. That means we will off this monitor, then this base, and then this draw. On the EBL computer, we will on the software exposure control program. So since the sample is coated with the electron beam resist, so we need to keep it away from the electron beam before writing. So here we are setting a position to move the stage. We are setting x0 and y20. It will move the system to this direction. And in our next step, we need to adjust the probe current. To adjust the probe current, here we need to increase this probe current to 7, value 7, and in the EBL computer we will go EBL, then beam control, and here beam on. Then we need to click the PCD. Now we see that the image from the screen will vanish, and we need to adjust this current to 100 picoampere. To adjust this, we will vary the probe current. We will adjust this probe current here, and we will set it to nearly 100. The next step, we need to click the blinker and close it. Now we are going to write the pattern in the sample, and for this we need to create a pattern file and a control file. We can load the pattern file from, there are some already made pattern file here, and we can choose from that. For patterning to start, we need to open these two, we need to make these two files. One is pattern file, another is control file. So in the pattern file, we will define the what type of structure we need. So here we are having a rectangular bar kind of structures, and we define the periodicity and the dimension of the structure here. In the next file, this is control file. In the control file, we can define here the current and the field size, and we call the pattern file here using this source file name, and we can also define from which coordinate we want to start the writing process, and how many array we want, and also we can define the dose scale here, and we can also define the dwell time. Dwell time is the exposure time for each of the pixels it will expose. Now for the calibrations, we need to search a 1 micron size particle in the sample, and we need to adjust it to the 15 to 20 micrometer field of view, and then we need to perform the calibration, which will set the reference point to start the writing process. So we are going to the same image. Same image to a 1 to 2 micron size particle, and we will keep it in a field of view of 12 to 15 micrometer field of view. Here we go to calibration. field calibration. EBL same image, then we'll adjust the magnification bar to 12 micrometer, and here we click done. Then we click calibrate field calibration. It is 200 micrometer field size, and need to select this file and open. Now the system will automatically calibrate the position, and it will refining the position coordinate. So we need to wait for the minimization of the error. Defines the error to a limit of 0.0005 to 0.0003. So we will again refine this error, and we will wait till it goes to 0.0005 to 0.0003. Stop. Here we have reached this error limit. It is 0.0003. And we can start the process. So here we'll save these field calibrations, and we'll overwrite this file. Here it is a default file is there, default 0200, and we'll overwrite this. After that we'll click abort. Now in the control file we need to update this origin, because we already calibrated the positions of the marking. And now we go to tools and map exposure origin, and it will update the origin positions. Now if you see carefully in the code, here this is the origin positions, this is the field size of 200 micrometer, this is the source file, this is the bar what we have made in the pattern file, and this x 2000 y is equal to 2000. It indicates that it will start the writing process from this origin point at 2000 unit x coordinate and 2000 unit y coordinate. So now we are ready to start the writing process. For this we can click this expose, and it will start the writing. After completing the writing process, to wind up the system, we can just close this software, ECP software, and here we will off the beam, and we can shut down this computer. We will set back this probe current to 6 and this acceleration voltage to 5 kV. And we keep the system at home position. To switch off this hardware, we will follow exactly the reverse process. We will first switch off this monitor, then we will switch off this base, and finally we will switch off this draw controller. We will set this same to back to the low magnification condition, and now we are ready to wind up the system. And for that, to keep the sample out, we will again use this rod. We will bend the system and we will wait till the shutter is closed and the system is ready to keep out the sample. So the blinking of this light indicates that yet the system is not ready. When this blinking stops, we can keep out the sample. Again, we will keep the system in evac condition. Thank you for this session.